Hey there, everybody. The final Thursday before spring break. Let's not quit now. Let's do some practice on the graphing stuff we were doing. So previously we were looking into different ways to graph. And so let's start off with, we have f of x equals x cubed plus 5x squared plus 2x minus 8. So we want to factor it. I can find the y here and we want the intercepts. So part A is find the roots or find the intercepts. So the y-intercept is pretty easy. Y-intercept is when x equals 0. So f of 0 is going to be negative 8. When y equals 0, then f of x has to equal 0. And so this is where we want the factored form. So we need to factor this bad boy. So let's do our p's and q's and see what we come up with. P is negative 8, so we could have 1 and 8 or 2 and 4. Q is just 1, which means our possible rational numbers are possible roots or possible rational roots in order are negative 8, negative 4, negative 2, negative 1, 1, 2, 4, and 8.
Can you hear me?
I can now.
I left and came back because my mic wasn't working. When you zoomed out, it did not refocus.
Okay, and I thought it was just my screen or like my Wi-Fi. All right, perfect.
Is it better?
Yes,
Okay.
but now
Let
it's
me
up.
pause and let you guys get caught up in. Because on the screen over here, it looked fine. If I count the sign changes, there's only one sign change, which means one possible positive root. Positive root, which means at most 2 negative. So it might be easier to focus on the negative roots first because I have 2 options and there's 4. I got like a 50-50 chance of hitting them. Something I noticed by looking at this is one of the homework problems. I just pulled it up like right before I turned on that camera. What I noticed from this is that there's only one negative the entire thing and it's negative 8, which means if this is going to equal 0, the rest of these have to add up to 8. And with cubes and shit in there, if it's a positive number, it's got to be really small. So like 2 already is x cubed. 2 cubed is 8. Everything else is going to be higher. I can see that those are out. I'm going to try x equals 1. Let me write that logic down real quick though. So these are all positive. So even if I start here, x cubed equals 2 cubed is 8. I have a minus 8 at the end, and then I have a plus 5 times 2 squared plus 2 times 2. These are 0, so without even calculating what that is, I know it's bigger than 1, bigger than 0. this is positive, which means this doesn't equal 0. And if I plug in anything higher, 4 cubed or 8 cubed immediately takes us out of the picture. So 2, 4, and 8 without actually trying very hard go right away. Just by looking at the equation going, I only got one negative. Now you can't always do this. In this case, we can. So now with that reduction, if I have a positive root, it has to be 1. So it's either there or it's not. Let's give it a try. Let's try that one. We'll bring down the 1. I got 6. That worked. Which means x minus 1 is a root. Or a factor. And now I don't need to keep doing it because I can take these numbers and make them coefficients of a polynomial that is 1 degree smaller. And I'm still trying to solve f of x equals 0. And there is an x minus 1 in there that I didn't write. Now that I've got it down to a quadratic, I can factor, and I don't need to try to do this P over Q shape. This is x plus 4 and x plus 2. And I still have my x minus 1. That makes sense? Does the reasoning I used to save some time on the P over Q make sense? No, kind of. So if you've only got one negative number or you only got one positive number and the rest is all negative, you can quickly see if you can overwhelm that number with big numbers. Because you start plugging in cubes and squares and stuff. It quickly, for any number bigger than 1, starts getting large really quickly. Now, if this was like negative 200, it'd be a different story. There's a lot of, I'd have to test them all, but it was only negative 8. That's probably not going to be the case in the next problem, and so we'll try something different. We'll do something different. But anything we can do to make our choices easier here, we want to take advantage of. Because we want to test as little as possible. And now that we have that, we have a crossing at negative 4. We have a crossing at negative 2, and we have a crossing at 1. And then f of 0 was negative 8. And I don't know that I gave myself enough room. The leading term is 1x cubed. So what we do after we have the intercepts is we got to look at end behavior. That's part B, end behavior, which depends entirely on that leading term. We have x cubed. So for odd ones, they point in opposite directions, either left one's down and right one's up, or opposite. When it's positive, you think about how x cubed normally looks all by itself, it's like that. That's a positive x cubed right there. So it has a left down and a right up, and ours is positive as well. So we're going to have a left down and a right up. And now all of these have multiplicity of 1. So they just cross the line. And I'll just start connecting stuff. This probably goes down like this and like that. I'm betting he does that because that would be a little bit smoother looking. Something like that. We're gonna pop over to Desmos and take a look at this bad boy and see what we get. This is always handy, at least on homework. You don't want to do it as your only way of finding shit. You want to be able to do it because you're not going to have this on a test. But you can always go to desmos.com and enter in your equation. So it looks like they had their thing going up a little bit higher here, but it does cross at -4. It does cross at -2. It crosses at 1. It crosses at -8. And my reasoning of having it a little bit to the left was right. It's about halfway between the two of them. So we did it right. Any questions on that one?
I have a question about like the possible, it's like where you said we could have one positive root and 2 negative roots. How do you get 2 negative roots?
It's a good question. I know the maximum roots are the exponent, the largest exponent is 3. If only one of them can be positive. The other way you can check it is you can plug in f of -x. If we do f of -x, this becomes -x cubed. X squared, if I stick in -x, I'm squaring it, the negative goes away and it's back to being positive. The 2x turns into -2x because the x is negative. And then I count my sign changes here, and I've got 1 here and 1 there. So there's 2 ways of doing it, but I kind of took a shortcut. Excellent question. I don't think I made that clear vocally. All right, you guys ready for more? That one's a little simple. Let's do this one. We'll go back to simple in a second. So we get 3. Let's do this. I could factor this. Holy shit. I could factor this without P over Q. I don't think you guys will do it though, so let's do the P over Q method first. So first off, we want to find our intercepts. So f of 0 is kind of easy, 27. Now we want to find where f of x equals 0, which means factor it. There are shorter ways of doing this. We've taught this before. When you have 4 terms, you can try grouping. When I'm going to come back to this later and do grouping. I can see 3 to 2. If I factor out a 9 out of these 2, I've got 2 here and 3 here. So I'm pretty sure I can factor this. But that's not always going to be the case, so let's go through and crank some stuff up. 27 doesn't have very many factors at all. We could do 1 and 27 or 3 and 9. Q also doesn't have very many factors, it's 1 and 2. So if we want our possible P divided by Q factors, well, it could be all the whole numbers. And then we could do it over to the 2 as well. And none of these numbers are even, so they're all just going to become that number over 2. This is 1.5. This is 4.5. This is 13.5. So if I rearrange them in a number line. And then I got the positive versions. There's a lot going on there. So let's look at doing the sign change test. How many times does this function change signs? 2. Changes signs here and it changes signs here. So it's got 2 sign changes, so we can have at most 2 positives. 2 positives max. And by recognizing that 3 is the maximum number, we could do 1 negative. 1 negative max. Now we just gotta, so there's more positive chances to, I got a better chance of hitting a positive number than a negative number. I'm gonna focus on the negative numbers. I don't know if it's gonna help me or not, but a lot of these numbers are multiples of 3. So I'm gonna focus on 3 first. 3's here. Even if it doesn't work, if it gives me all positives, I can cancel out a bunch of numbers like that. So I think 3 is a good starting point. Does that reasoning make sense to everybody? I got a lot of multiples of 3, and I think if I'm going to end up with something that's a factor, if it's got a fraction in it, I don't know how I'm going to multiply and end up with a 27. So I'm thinking all the halves are really not going to be good options at all. So I'm going to focus on the numbers, and a lot of them look like multiples of 3. Good number to start with. And it worked. X minus 3 is a factor. And what we have left over, these are the coefficients of a polynomial that is 1 degree smaller. Something that, oh, that should be a -9. Something that multiplies to negative 18 but adds up to 3. Uh, 6 and negative 3. 6 and negative 3 work. So we'll do some grouping here. I've got a 2x there times x plus 3 and a negative 1 times x plus 3. So if I finish grouping, I have x minus 3 out front. I have an x plus 3 here. And I have 2x minus 1 here. I guess that's how a 1/2 gets into the mix right there. It shows up as something time clears out the fractions. So my roots are 3, negative 3, and positive 1/2. Before we go on to graphing it, I want to point out what I was talking about earlier. If there's only 4 terms and you spot it right away, it's always worth giving it a try because it speeds it up substantially. These are both multiples of 9. So if I took out like a 9, I would have 2x and a 3. If I do that over here, if I take out an x squared, I'm going to have a 2x and a 3 also. And it looks like I want it to be negative here. So I want a negative here and I can do negative there. I said negative 1 here. That is so not right. That is a 3. And I see it doing the factor doing this approach. So this is x squared minus 9 times 2x minus 3. I made a mistake. How about that? And no one said anything. Chris, you're supposed to be my wingman. So doing it by grouping is a lot faster there. I avoided all this crap by doing it by grouping. It's not always there. It's worth a try if you spot something. It's worth a try. It could save you a lot of time. So that's what I did here by grouping methods.
Once you do systematic division, so at the point that you have like 3 terms, then that's where you stop.
I stopped here because I'm down to a quadratic. I could keep going, but doing quadratic methods is now easier. Even if I just go straight to the quadratic formula, you know, negative b, that whole jazz, it's still faster than testing all these. So the idea is not waste time when you don't have to. All right, so we can go to drawing it. My factored form is x minus 3, x plus 3, 2x minus 3. How can I check to see if that's right? Like earlier, I had said 2x minus 1, and I didn't even bother to check it. I probably should have, because I would have been able to tell right away it was wrong. How can I check my work before I start graphing?
My thought would be the 3 times the 3 gets a 9, and then the 9 times 3 gets 27. So the fact that you have those ends means that you have the negative 27 at the end.
That definitely speeds it up, yes.
Or the
In
positive
fact-
27.
Yeah, I have a positive 27. That's a good start. I've got, if I multiply the end ones, I've got positive 27s. If I multiply the front ones, I've got 2x cubed. I've already managed to get this one and this one verified. The other option is just multiplying all the way up. But doing some quick stuff will check the two end ones. And that's, you know, if you're gonna make a mistake, it should likely fuck up the end ones. So in case you didn't catch what he was saying is take this, this, and this and multiply them together. Bingo, 27. And I added on top of that, you could do it with the front ones too. And that showed up there. That definitely is a good way of checking. If you want to check the whole thing, you could just multiply it all the way out. I didn't bring my gloves. I'm getting ink all over my hands again. Amateur hour over here. Telling you, it's a complete rookie up here. I'm going to say that's 27. Even though I clearly have not drawn the y-axis on the same scale that I've drawn the x-axis. Because 27 is going to be way off the screen, and I don't want to do that. So we have our equation. We want to start looking at what we can do. We already know where they cross. We know it crosses at -3, +3. And if I said 2x minus 3 equal to 0, I get x equals 3/2, which is right there. I also know I have a y-intercept way up at 27. My leading term was 2x cubed. So cubics either do this or they do this. Since it's positive, it's doing this one. Which means I know it goes down on the left and up on the right. And each of these have multiplicity of 1. So they just cross. So it's going to cross there, it's going to cross there, it's going to cross there. Now we just start connecting the dots. Look at that, that was beautiful. Beautiful.
I had a thought.
With a,
Once you have the roots, it's actually really easy to check like where points would land. For example, I put 2 in and I got -5. So you can know that like in between the 1.5 and 3, it goes a little bit lower.
oh yeah. Yeah, you could, it's definitely quicker. I think it's actually probably quicker in the factored form than the original. Because I can see 2 minus 3, 2 plus 3, I got -1, 5, and then 1. Oh wait, I'm plugging in 2. Yeah. 1, 5, and 1. Wait, 1, 5, and -1, 5, and 1. So it multiplies to -5. Yeah, this my y-axis is not to scale. So keep that in mind. If this is 27, this might very well be 5.
Yeah, actually, yeah, I see that now.
Okay. Let's see. Let's do. Which one of these looks like fun? We just did those. This looks like fun. I'm gonna have to share the camera. Finding the equation from a graph. So I'm going to write down what I'm saying as I go. They give us the formula up here. They tell us what the formula is. So we know what the final form is. They're telling us to factor just by looking at the graph. So what do we know by looking at the graph? If the end behavior points both upwards, then we know we have an even polynomial. And we can see we do, it's x to the 4th. So we got that pinned down good. The factors really come from where does it hit the x-axis? So I can see it's hitting the x-axis at -4. So factor from graph. This was problem 6 in the homework. And they gave x to the 4th plus 3x cubed minus 24x squared minus 80x. And I'm going to scribble down this graph real quick. That way it's in the lecture notes. And I will put the camera on after that. So I got it coming down. It comes down, the graph hits -4. And it bounces back up. And it crosses at 0. And it crosses at 5. So I can see from the thing that I have, it hits x equals -4, it hits x equals 0, and it hits x equals 5. That's where it touches the x-axis. So if I solve the right side for 0 by adding the coefficient to the other, or subtracting the coefficient to the other side, I have x plus 4 equals 0, x equals 0, and x minus 5 equals 0. And then we have a little bit more information that we can get from the graph, because I only have 3 x's here, which means this is only going to be x cubed the way I have it. What should I change here? And why?
X minus 4 rebounds off it, so it has a multiplicity of 2.
Yes. Or at least a multiplicity of an even number. Since it bounces here or rebounds, it's got at least a multiplicity of an even number. And since we only need one more x, it can only go up to 2. Now the number in front is 1, so that looks pretty good. And we can do the little test that Chris was talking about earlier, because this is x plus 4, I'll put the x in front now, x plus 4, x minus 5. So if I multiply all the x's, I get x to the fourth. If I multiply the n numbers, I got 4 times 4 times -5 is -80. And that's what I have showing up on the last term. So that looks like it's probably pretty good. Let's do another one. I'll leave that, and I'll leave the graph up for you guys to do. I want you guys to try to do it, and then we'll do it as a group. It says f of x equals -x to the fifth plus 72x cubed minus 130x squared minus 471x minus 270. Wouldn't that be fun to graph by hand, like factor by hand? These left and right things, let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So left and right, each hash mark is 1, which is helpful to know. Once I have this regraphed, I will change the camera back to the computer. Let's see, 1, 2, 3, 4. Well, this looks, just to help you guys with the counting, that looks like -1, that looks like -9. That's 5, and that's 6. What'd you guys come up with?
I got x plus 1 squared and x plus 9. X squared.
Anyone else get that?
I did, but but like when you do the check to, when you multiply the last digits and see if it gets the ending coefficient, it gets positive 270.
It does. You can also see that x to the fifth is negative, and we have no negative x's here.
Hmm.
We throw a negative in front, it works. You have the option of moving inside one. I would probably do something like, I'd leave the ones that are positive alone. Maybe say 5 minus x on one, or change the x minus 6. That would do it as well. I like this best because it keeps the x's in front. But either one of these would work. Equals 0 only gives me the x-axis. All right, class starts in 5 minutes. Or not 5 minutes. We have only 5 minutes left. Let's call that wrapped here. How's everyone doing on the homework and stuff?
I'm definitely gonna
Challenging?
take your advice and catch up on my homework this break because I'm behind.
Okay, I don't know if anyone else saw it. I did that today. And I was gonna wait till main class. Yeah, all the old homework is open back up. I would definitely focus on chapter 3 onward first. And if there's something in it that you don't get that you think was based off previous stuff, go back then. But most of your stuff on the final is going to be chapter 3 onward. So you're better off starting there. And if you have more time and want to go back and do other stuff, go from there. I like doing that over break because it incentivizes students to not fuck off over break. Is the worst thing. Spring break and Thanksgiving break really just rape students. Just fuck so many students because it's right before the end. They've been going to school for like 12 weeks at least. They're fucking tired of going to class. They're tired of doing homework. They get a week off and they use it for a week off and they get in vacation mode. And even top students, they don't work over break. They come back from break, they're in vacation mode still, and getting out of vacation mode is a bitch, especially when you've only got a couple weeks left. You just gotta dig in there. So using spring break as a vacation time is terrible unless you still get some work done. Yeah, you don't have to work all the time on it, but at least if you're doing a little bit of math over the vacation, you're not gonna lose it. If you want to get caught up, this is a great chance and incentive to do it. And that's why I'd like to open up all old homework over break. Because I know how easy it is to just blow off. Like, nope, I'm taking a week off, playing video games, I'm doing this or that, I'm going to the movies, blah, blah, blah. John Wick came out, Shazam's out, Dungeons and Dragons out. There's another movie that came out that looks like had a bunch of good actors in it. I don't even know what it's about, but by the actors I wanted to see, I don't even remember what it's called. I haven't been in the movies in a while. I'm going to the fucking movies over break. But I'm doing work over break too. I got grading to do. I got I want to get you guys' tests ready so that I'm not doing it over the rest of the semester. I got to revise the featured homework schedule because we're a little bit behind. I've decided to deliberately do that. I've slowed down this week because this is a hard week. And stuff at the end isn't technically part of what needs to be taught. But it does show up again later. So if you've seen it already, it's helpful. I'm going to try to get to as much of that as possible, but definitely want to focus on what you guys are need to know the most. So I'm not taking the vacation off. I hope you guys don't either. Let me hit stop record.